their traits if they can't get across, and it creates more edges. See the light green area? This is called the edge effects that happen at boundaries of ecosystems. So different effects that you might not see without all those edges. Another factor that greatly impacts biodiversity is pollution. Pollution is changing the composition of air, soil, and water in the biosphere. This image is showing a type of water pollution called biological magnification. Think about a magnifying glass. When you put it on something, it makes it larger than it appears. It appears larger than it actually you would think it is. So this shows biological magnification of a pollutant in water. Let's say a pollutant like DDT, which was a pesticide used to kill mosquitoes heavily in the malaria epidemic scare in the 1950s, or something like mercury gets into the water somehow. The parts per million, that's the unit, is not very large in the water level. The producers use the water to grow, so they take in that polluted water. Zooplankton will eat the producers. Small fish will eat the zooplankton. Large fish eat the small fish, and fish-eating birds eat the large fish. As the food chain goes up to the higher organisms, the pollutant gets more concentrated or magnified. So although in the water it was 0.000003 points per million, by the time that pollutant gets into the blood of the fish-eating bird, it is now 25 parts per million, highly concentrated. And this caused some problems. Scientists saw that these fish-eating birds were laying eggs that weren't able to withstand the normal environment. These eggs shells were brittle, and they weren't as likely to make it to actually hatching, so thus decreasing the population of fish-eating birds. So they outlawed DDT, for example. You might have heard of somebody telling that you can't eat a lot of tuna because you might have too much mercury in your blood. That actually is somewhat true. I'm not saying that you should never eat tuna, but you probably shouldn't eat it 7 days out of the week. There is a little bit of truth to that. That's because of biological magnification. Other type of pollution, air pollution, one example is acid precipitation. When factories give off gas, sulfur, nitrogen, it mixes with the water vapor in the air and rains down acid. And what that acid rain does, it removes calcium, potassium, and other nutrients from the soil and deprives plants from the essential nutrients for them to grow. It also can corrode different things. Another example of pollution, it's called eutrophication, where the oxygen is sucked out of the water, and it's due to excess nitrogen and phosphorus, which we've already talked about. So it causes excessive algae growth in the water, which you might think, well, that's not bad because algae is food and it can feed organisms. Maybe, except that the algae uses up all the oxygen supply, and then fish, like in the picture, doesn't have enough oxygen and they suffocate. And this shows again the average consumption rate of natural resources and how it's not evenly distributed. You can see that United States and Canada use way more than compared to Bangladesh, India, Kenya, all those countries. So there is not a balance to the amount of resources that we use. Renewable resources. Some resources that we need, that we get from the environment, are renewable. What that means is these are replaced by natural processes that are replaced faster than they are consumed. So we don't really worry about them because they can be replaced quickly. These are things like solar energy. The sun is going to shine. Agriculture plants, animals, clean water, clean air. They are renewable. Non-renewable resources, they're found on Earth naturally, but they're in limited amounts. And to replace them, it doesn't happen quickly. It takes long periods of time to replace them. So they're considered non-renewable. So fossil fuels, mineral deposits are an example of non-renewable resources. So, and also the classification of those depends on the context, like the area, what's happening at the time, because a lot of people, clean water might not be renewable if we continue to pollute it and not use it wisely. So that leads me to my next point. To wisely use resources is called sustainable use. It means using resources at a rate at which they can be replaced or recycled while preserving the long-term health of the biosphere. Keeping in mind that we need water, we need to use fossil fuels. That's true. But how can we do it in a way that protects the environment long term? That's sustainable use, and that's something that should be thought about before things are done. Another effort to protect biodiversity is to keep in your mind these things called biological hotspots. A hotspot is a place in our biosphere that has at least 1,500 endemic, natural plants, and has lost a lot of its habitat already. So they are areas of concern, essentially, that things aren't going well there. We want to work to preserve that area. These are called biological hotspots. Species that are endemic are only found in one specific geographic location. So a lot of times efforts are focused heavily on these endemic species because they're only found in this one spot. We want to protect this one spot. And the interesting thing about these hotspots, of all the plant and animal species in our world, these hotspots contain half of all the plant and animal species. There are efforts to control or to protect our biodiversity. For example, there are corridors between habitat fragments that allow animals to move safely between them. I'm going to show you an example here. I have a picture of one. This is in Banff National Park, which is in Canada. Here is a road that went through this ecosystem. You can see it there. And they put a bridge over the road so that animals can get from one side to the other. I have driven through Glacier National Park, and they also have those. So that's an example of a corridor. Restoring ecosystems. Ecosystems can recover from disasters or human-made disasters, but it takes some time. The larger the affected area, the longer it takes for that community to recover. And this is a nice graph that shows you that. Here's the size of the area affected from small to large and the recovery time. So a tree fall or a lightning strike doesn't take very long for that area to recover. Something like acid rain or a tsunami, volcanic eruption, urbanization affects a larger area and takes a lot more time to recover. There are two ways to restore ecosystems. One is called bioremediation. That's in which prokaryotes, such as fungi or plants, are used to detoxify a polluted area. Here is an article that talks about using bacteria, I believe, if it's still there, to clean up oil spills. How microbes will clean up a Deepwater Horizon spill. So, using natural efforts to clean up a not natural thing in the ocean, for example. That's bioremediation. Biological augmentation is adding natural predators to a degraded ecosystem. So here is a picture of a lady beetle and some lacewing, or no, those are aphids, and adding these lady beetles that are good to eat those bad insects would be an example of biological augmentation. There have been efforts through the United States Endangered Species Act in 1973 to protect endangered species or ones that are in danger of becoming extinct. In 1973, and efforts are being made currently to, or that have been made to outlaw trade of endangered animals, but yet it still happens, which is sad. Killing of gorillas, maybe you've heard of illegally transporting birds like parrots. There was a movie, I forget the name now, about that. There's all sorts of things that people will do for money that are affecting our biosphere negatively. So there's been treaties, acts done to protect our biodiversity.